Thanks for the sports update, Jill. Kia ora guys, welcome back to the show. Now, we all know that back in the day, all land on Earth was joined together creating one big supercontinent. But let me ask you this. Have you ever wondered how the splitting of Earth's landmasses affected the biodiversity of plants and animals in the country of New Zealand? I'll hand it over to journalist Sally Porter to explain. Thanks for that, Roger. Now, over 250 million years ago, only one large mass of land existed, Pangaea, the supercontinent. Over time, this landmass separated into two subcontinents, Laurasia in the north and Gondwana in the south. These continents existed for approximately 80 million years before they began to break up into the remnants recognised as the continents of today. The land that was to form New Zealand broke away from Gondwana 80 million years ago and completely separated 65 million years ago. This means that New Zealand has been an isolated island for over 65 million years. This also means that species in New Zealand haven't had the opportunity to interbreed with other individuals of their species. No interbreeding means that New Zealand species have gone off on their own evolutionary path. 66 million years ago, a big event, whether it was a meteor or what have you, wiped out the entire dinosaur population. Before that, reptiles dominated the lands. Once they were gone, they left behind big gaps in almost all existing ecosystems. Across the world, mammals began to fill the ecological niches they left behind. Well, basically everywhere, except for in New Zealand. Over here, birds evolved to occupy habitats right from the seas to the vastly bare mountain tops. To fill the many niches left behind, New Zealand's birds had to evolve in an incredibly unique way. Some got massive, like the moa and the Haast seagull. This is mostly due to island giganticism. Some people believe that they got so big because they evolved through many glacial periods, just like the saber-toothed tiger and the woolly mammoth. Other New Zealand birds lost the ability to fly, like the kiwi and the kakapo. This was due to the lack of mammalian predators and the abundance of food resources available on the ground for these flightless birds. There are three kinds of adaptations that plants and animals go through when they're evolving. These are structural, physiological, and behavioural. Structural adaptations change the physical appearance of a species. For example, tail or no tail, ears or no ears. Physiological adaptations change what's on the inside. For example, a change in cells or chemical makeup. Behavioural adaptations are changes in innate behaviours like hibernating animals, nocturnalism, and any sorts of mating rituals. New Zealand's plants and animals have used these three different kinds of adaptations to fill the ecological niches in New Zealand's ecosystem. Animals in New Zealand evolved in a strange way because of the odd set of survival pressures put on them. Because there were no mammalian predators on the land, our bird species could move down some pretty hectic evolutionary pathways. For example, the moa. Now, there are several species of moa, 9 to be exact. Small bush moa are about the size of a turkey, about 1 metre tall. However, large moa, like the giant moa, could reach 3 metres in height. The moa are herbivores. Normally, large herbivores find it hard to escape or hide from predators. However, on islands like New Zealand, there are few or no large predators to contend with, so plant eaters, such as the moa, were able to grow very large. This is a recognised process called island giganticism, basically meaning that with few predators, the species could thrive. Another crazy evolutionary fact about moa is that they're the only bird on record to have absolutely no wings. Like many flightless birds, they once had them, lost the need for them, and therefore they began to evolve smaller ones. Plus, their size didn't exactly mean they were the most aerodynamic birds to be flying around. However, no other bird has lost all traces of their wings like the moa has. Right from the bones and the joints to the keel, which is an extension of the sternum or the breastplate that muscles supporting the wings would normally attach to. Crazy! Another wee fact about the moa is that they were believed to grow really, really slowly, taking about 10 years to reach their full size. This is hectic compared to the birds of today, which often take no more than 12 months to be fully grown. Scientists believe that it took them about 10 years due to studies they've performed on the growth rings of moa bones. Haast's eagle are another bird of New Zealand that has a pretty radical evolutionary pathway. Haast's eagles were top of the food chain animals and were the only known predators of the moa until Māori arrived in the early 1200s. Haast's eagle, named after Julius von Haast, were the biggest eagle ever recorded, weighing in at around 15 kilograms and having a 3-metre wingspan. They also have an incredible evolutionary story. It's believed that they grew so large in an evolutionary response to the size of their prey, the moa. Their closest identified relative is the little eagle of Australia, which only weighs under 1 kilogram. Haast's eagles derived evolutionary paths from them around 2.2 million years ago. This means that if they were that small at the start of their evolutionary journey, then the process of their evolution to get 10 to 15 times bigger in just 2 million years is one of the fastest evolutionary increases in any known vertebrate species. Thanks for that, Sally. That's so fascinating. Who knew New Zealand was such a unique place? Now over to Lisa for the weather.